Good morning, everybody. So I'm Southey from Terraclim, a forward farming solution, harnessing technology for more resilient agriculture, specifically looking at how we're shaping orchard for the future. So the project title, and thank you, Hortgrove, for the opportunity to do this research, was to look at the climate profiling and change analysis of the main Elgin-Grabouw-VyeboomVilliersdorp production area, Koue Bokkeveld and Langkloof, and to look at what has happened over the last 8 seasons and how do you profile these production zones. So these are the main areas that we looked at, green being Koue Bokkeveld, red Langkloof, and the blue Elgin-Grabouw-VyeboomVilliersdorp. The project was split into 4 main objectives. The objective was to generate high-resolution terrain derivatives, slope aspect solar radiation. Second objective was to generate high-resolution climate layers. So we're looking at an hourly layer for every hour of the day, then daily, then monthly. Objective 3 was to aggregate that into bioclimatic indices, chill units, heat units, and then specific thresholds that are applicable to apple production, hours above 35, hours below 18, and then we reported on what was the spatial differences. These are the weather stations that we use in each of the production areas. We use METAR stations, which are the blue points, vital weather, which is the red points, and iLeaf, which are the green points. We then took that and we created these maps, and all this data is available in our reports within the Hortgrow environment. So on the you can see the low areas is where you're going to, and this is Elgin-Grabouw-Vyeboom area. The red is the low areas, the higher chill units and heat units. Higher grain degree days, is the green. And so we took the points on this side, we created these maps. And this is a standard deviation maps. These maps are extremely important. That's an 8-year mean on the side, and then the middle is the standard deviation of those 8 years. So the darker red areas shows you larger variation of 200 units in your grain degree days from season to season. Lighter areas, you're looking at 50 units. So that's really important when it comes to what is the consistency that you're seeing from season to season. Then looking at another bioclimatic indice, heat unit, grain degree hours, and if you compare the two, look at the top left-hand corner, if you just look at the spatial variation that you see just using 2 different heat units. So it's really important in your area to start quantifying what heat units you use and look at all of them and identify where the variations that you're seeing over space and time. Standard deviation of that, you can also see the higher areas showing higher variation in heat units from season to season, and then areas with lower variation. Looking at the Koue Bokkeveld, throughout the Koue Bokkeveld is cooler. I know this is counterintuitive, red being hotter, but the red is cooler, and you can see in the Warm Bokkeveld we're starting to get higher heat units, which we all know and obvious. But what's interesting, when you start quantifying that back to variation, areas with lower heat tend to have more variation from season to season. Areas with higher heat units end up having less variation from season to season, which is quite an interesting finding when correlating it back. Langkloof, you can see is cooler throughout the Langkloof. Again, just pockets where you're getting higher chill heat units. And Langkloof, having the lowest amount of heat units, ends up having the highest amount of variation from season to season. So it comes back down to the cultivar choices and the management in season. Now, taking those maps that created the mean and you separate them, which was another interesting pull-out finding across the regions, was 2019 and 2020 for Elgin-Grabouw-Vyeboom area were the hottest out of all 8 seasons. When looking at heat grain degree hours, 2023 was the hottest. Then looking at looking at Koue Bokkeveld, 2021 was the hottest year. And then looking at Langkloof, 2022 and 2023 was the hottest year. So it's really interesting how all the regions responded differently in the context of what was the hottest out of the 8 years in the context of just change. Then graphically looking at this is daily positive chill units, the Infratech model. The blue line is Koue Bokkeveld, a lot more chill. And then the comparable chill variation between Elgin and Langkloof. But you can also see the seasonal variability, how it goes up and down over the different seasons. So in the bottom, you've got 2016, all the way to 2023. Looking at grain degree days, Elgin has the higher amount of EGVV, has the higher amount of heat units, and then you've got Langkloof, then Koue Bokkeveld. Interesting finding with the Langkloof, a lot more hours above 35 and jumping across seasons. So you get seasons where there's a lot and then less, and that is a sunburn effect. And then hours below 18, you can see this is a significant amount of difference in season to season. And these are conditions around flowering, unfavorable conditions around flowering. And then if we look at this summarized, which gets a little bit more complex, I'm just going to jump now. So you've got heat units and chill units, which is a large variation. Again, warmer areas, you're looking at the Elgin-Grabouw-Vyeboom, and this is obviously all driven by topography. Koue Bokkeveld being higher, but the trends that we're seeing over the seasons, cooler winter conditions over the last few seasons have been evident. Understanding when it's getting cooler and warmer is important in that. And then the most consistent summer conditions across the areas with slight increases in the summer temperatures in the most recent years has been very evident. So all of this is available in the Hortgrow reports, and you guys can scan the QR code, and this is where Hortgrow releases the monthly climate reports, and a lot of this information's in there, which is really interesting. Thank you very much.